Sorry. Okay. So, yesterday we have studied a decay constant. Okay. So, the next concept which we are studying is half-life. So, what is half-life? Write down. So, time taken for half of the atoms to disintegrate. Okay, ma? So this time is called as half-life. Are you able to understand, ma? Time taken for half of the atoms to disintegrate is called as half-life. So what is the meaning of this one? Let us see. See, ma, for example, we have 100 atoms. 100 atoms are present which are undecayed. Undecayed means what? Undecayed means they have not emitted alpha, they have not emitted beta, or they have not emitted gamma also. That is called as undecayed. And next, these 100 atoms, they should convert into 50 decayed atoms plus 50 undecayed atoms. Are you able to understand, ma? So half of the atoms should disintegrate. And what is meant by disintegration? Either emission of alpha or either emission of beta. If alpha is emitted, then also it is called disintegration. If beta is emitted, then also it is called as disintegration. So therefore, 50 atoms should be undecayed and 50 atoms should be already decayed. Then this time taken is called as half-life. Are you able to understand, ma? And half-life varies from material to material. So for some elements, half-life may be some thousands of years also. For example, if you take carbon 614, half-life is nearly some 5,640 years. Are you able to understand? And for some more isotopes, it is only 16 minutes or 17 minutes only. Are you able to understand, ma? So what is meant by half-life? Time taken for 50% of the atoms to disintegrate, and remaining should be how much? Remaining should be 50%. So that time is called as half-life. Are you able to understand? So mathematically, let us see how we can calculate this one. Already we have written the equation of radioactivity decay yesterday. No? N is equals to N naught e power minus lambda into T. This already we have studied. No? Yesterday we derived this one. What is meant by N here? N means number of atoms which are undecayed. Number of atoms undecayed. Are you able to understand, ma? N naught is equals to initial number of atoms undecayed when we started observation. That is the relation between N and N naught. Okay. Now see. So therefore, after half-life, okay, ma? N will become N naught divided by 2, no? Is it correct, ma? After half-life, how many atoms should be there which are ready for disintegration? It is only half of original number of atoms. Ante kada, ade kada half-life ante. Clear, ma? So after a time of T, how many atoms should be there which are ready for disintegration? N naught divided by 2, where N naught is initial number of atoms. So substitute here. So therefore, instead of N, what I will write? N naught divided by 2. So these many atoms are left. And this is equals to N naught e power minus lambda into capital T 1 by 2. Okay, ma? And for half of the atoms to decay, what is the time taken? Time taken is called as half-life. So that is why instead of small t, I am writing T 1 by 2. Are you able to understand? Now see what are the terms which get cancelled. So N naught and N naught, they will get cancelled. Okay, ma? So therefore I can write 1 by 2 is equals to e power minus lambda into T 1 by 2. This is what I can write. Okay. Now if I want to remove this symbol, I can do one thing. I can write 2 is equals to e power lambda into T power 1 by 2. I can write like this. Are you able to understand? And now if I want to apply logarithms, how I can write is log 2 to the base e is equals to lambda into T power 1 by 2. This is how I can write. This is the method of applying the logarithms. Okay. So you ask your mathematics madam. Further she will explain how to apply the logarithms. Now logarithm methods I cannot explain you. Are you able to understand, ma? So when you apply logarithms, this is what you will get. Okay. So therefore, what is half-life? T half-life is equals to log to the base e divided by lambda. So this is the equation for half-life. Are you able to understand, ma? So half-life means what? Time taken for half of the atoms to disintegrate. If half of the atoms are disintegrated, remaining is half, no? Half of the atoms are left which are undecayed. Okay. So equation is log 2 to the base c, that is natural logarithm of 2 divided by lambda. This is the equation.
2 power lo undi 2 into log e. 2 into log e.
2 into, no, I cannot write like this. If it is 2 square, then 2 will come to this side. But here I am taking log of 2, no? So 2 will not go to the other side. Are you able to understand, ma? Same equation I can also write t half is equals to 0.693 divided by lambda. Because, what is the reason? Because since log 2 to the base e is nothing but 0.693. Are you able to understand, ma? So this is the equation for half-life. So half-life depends on what? Half-life depends on decay constant. Okay, ma? So if decay constant is greater, half-life will be lesser because they are inversely proportional, no? And what is meant by decay constant? Decay constant ante ninne em chadukunnam manamu? Cheppandi. Decay constant means number of disintegrations per second. That is called as number of disintegrations per second and divided by the number of original number of atoms. That's what we have studied, no? Okay, ma? It means if decay constant is greater, so the element will disintegrate more rapidly. So half-life will be lesser. అర్థమవుతుంది కదా? If decay constant is greater, half-life will be lesser. Decay constant ఎక్కువ ఉంది అంటే మీనింగ్ ఏమి? For available number of atoms, more atoms are disintegrating. That is called as decay constant, no? Clear, no? All the definitions you should remember very, very, very carefully. Clear, no? So therefore I can write half-life is inversely proportional to lambda. That is, if lambda increases, half-life decreases. So this is the equation. Okay, ma? And similarly, from the same equation, you can write a lambda is equals to 0.693 divided by t half. You can write like this also. Understood, no? Make a note. Antavaraku rayandi. Okay, now see, ma. So we are discussing some very useful equations to calculate half-life. Okay, so listen carefully. So at t is equal to 0, what is meant by at t is equal to 0? When we started observation. That is the meaning of this one, Nama. When we started observation, the number of atoms which are ready for disintegration or number of atoms which have not disintegrated is equals to n naught. So from the starting of the chapter also same numerology we are using, no? So number of atoms at the initial position is n naught. So after one half-life, what is meant by half-life? Time taken for half of the atoms to disintegrate. After one half-life, that is when t is equals to t half, okay, ma? How many atoms will be left, ma? Only half of the atoms have disintegrated and half of ready for disintegration. So therefore, n means number of atoms which are ready, and that is equals to initial number of atoms divided by 2 only, no? That is the meaning of this one, no? Half-life tarvata sogam lechipoyinayi, sogam unnai annamata. Are you able to understand, ma? So half of the atoms are present. So n naught divided by 2. And n naught divided by 2, I can write n naught into 1 by 2 power 1 also, no? Okay, ma? It means that here I have 1, here also I have 1. Is it clear? Next let us write one more condition. And after second half-life, okay, ma? That is when t is equals to 2t half, okay, ma? One half-life is completed. Half of the atoms are remaining. And after one more half-time, then what will happen? Clear, no, ma? Then again I can write, now the number of atoms is n naught into 1 by 2 power 1 divided by 2. That's all, no? Okay, ma? After one more half-life, what will happen? This is the total number of atoms which are ready after one half-life, no? And in that half-life, again half of the atoms will be decayed and half of the atoms will be present. So here we got already half atoms, no? In that again half. For example, let us take n naught is equal to 1000, example. After one half-life, how many atoms are present? 500. After one more half-life, now it should be 250 only, no? It means 500 again I have to divide by 2. So therefore, this equation I can write it as n naught multiplied by 1 by 2 power 1 plus 1 is 2. Okay, this is how I can write. So it means after two half-lives, first half-life, second half-life, how many number of atoms are available, ma? N naught into 1 by 2 power 2, 1 or 1 by 2 whole square. Like this I can write. Clear, no? Now let us go for after third half-life. Okay, ma? Third half-life, that is, what is the time? T is equal to 3 into t power 1 by 2. Okay, ma? 3 times the half-time. Now how many atoms will be there, can you say? N is equals to n naught multiplied by 1 by 2 power 2, again divided by 2. That's all. It means here now I have 250 atoms, no? 250 atoms should become how many atoms? 125 atoms. So this equation, how I can write? I can write n is equals to n naught multiplied by 2, 1 by 2 multiplied by 3. Okay. 3 half-lives, number of atoms is n naught into 1 by 2 power 3. Clear now? So therefore, after nth half-life, okay, that is how much time? Time is equals to 4 into t power 1 by 2. Okay, so okay, how can I calculate? N is equals to n naught power 1 by 2 whole cube divided by again 2, again half. So again how many? 125 divided by 2. 125 divided by 2 approximately 62.5. Clear nama? So therefore n is equals to how much this one? N naught, no, after n we are writing no? So this will stop here. So n naught into, so directly I will write, no need of all this. I will write n is equals to n naught multiplied by 1 by 2 power n. This is how I can write. Okay. Here also instead of this one I can write. After nth half-life, so same sequence if I follow. So what will be the total time? Total time will be n into time taken for each half-life. Okay, ma? So therefore here also, if it is 3 half-lives, here in the numerator I got 3, no, power 3. So here I will get power n. So this is the general equation to calculate number of atoms which are ready for disintegration after n half-lives. Okay. So n value, how can I calculate? N value is equals to, n value means what, ma? Number of half-lives. N is what? Number of half-lives. Okay. 3 means 3 half-lives, no? 2 means 2 half-lives, no? So n means n half-lives. And n value is how much? Total time divided by time taken for 1 half-life. Are you able to understand? So this is the equation to calculate number of half-lives. Okay. So this is the beauty of radioactivity. Now see, listen very carefully. So initially consider 1000 atoms are present. Okay, 1000 atoms should convert into 500 atoms. And let time taken is 1 hour. So therefore 1 hour is nothing but half-life, no? What is meant by half-life? Time taken for 50% atoms to disintegrate. And the time taken is 1 hour. Okay, ma? So 1000 has become 500. Now 500 should become 250. Again half of the atom should disintegrate. Now what will be the time taken? Can you say? 1 hour only. 1000 atoms have converted into 500. It means how many atoms have disintegrated? 500 atoms have disintegrated. And time taken for 500 atoms to disintegrate is 1 hour. Clear? Now how many atoms are there? 500. From 500, 250 should disintegrate and 250 should be remaining. Then what will be the time taken? Half an hour, no? No. But the time taken is again 1 hour only. Okay, ma? Half-life always remains constant for that particular material. Are you able to understand, ma? So from 1000 to 500 also 1 hour. 500 to 250 also 1 hour, 250 to 125 also 1 hour, 125 to 62.5 also 1 hour. So this is how radioactivity behaves. So based on that logic only we have done this total calculation. Okay, ma? So to become from n0 to n0 by 2, time taken is 1 half-life. Okay, and n0 by 2 to n0 by 4, time taken is another half-life. So total half-lives 2 into 1 by 2. Time taken from 1 by 4th to become 1 by 8th, again half. Again time taken is 1 more half-life. Understood, Amma? This is how radioactivity will behave. 1000 నుంచి 500 వచ్చిన దానికి 1 hour, 500 నుంచి 225 వచ్చిన దానికి half an hour అని కాదు. Again it will take say 1 hour only. Okay, ma? So therefore to become 250 to 125 also 1 hour, 125 to 65.5 also 62.1 hour. This is called as half-life. Okay, ma? So write down. So 250 to again 125 also 1 hour. So 62.5 also 1 hour. Therefore, what is the note point we have to write? Okay, ma? So for every half of the atoms to disintegrate, disintegrate, same time is taken. Same time is taken. This is the most important point in radioactivity. Are you able to understand? Clear now what is happening? So this is one very beautiful equation to calculate the number of half-lives, or how many atoms are present after a particular number of half-lives. Okay? So write down one question. Write down one question. Question is, shall I rub this? A radioactive substance has a half-life of 16 days. Okay, ma? Find the fraction of atoms decayed after 64 days. That is the question. Okay? Come on, try to do this question. Kotta problems chesetappudu. Okay, ma? Now see. So this is the given question. No, radioactive substance has a half-life of 16 days, and find the fraction of atoms decayed after 64 days. Okay, ma? So formula already we have studied now. N is equal to N naught power 1 by 2 power M. This already we have studied. Okay. And what is meant by N? Total time divided by half-life. This also we know. Okay. First of all, without using this one, let us proceed in the general fashion. Sima. So after 16 days, one half-life is completed. No? One half-life is completed. So if initial number of atoms are N naught, then it will become N naught by 2. That's all. No? After one half-life, if original number of atoms are N naught, half of the atoms have disintegrated and half of the atoms are ready for disintegration. Now see. So after one more half-life, that is 32 days, 16 plus 16, 32 only, Rama. After 32 days, second half-life will be completed. And after second half-life, in this one, again half of the atoms will be disintegrated. Clear, no? So total they will become N naught divided by 4. Okay, ma? Are you able to understand? Now what is meant by N naught by 4? These many atoms are present for disintegration. Only these many atoms are present for disintegration. Are you able to understand, ma? So after 48 days, how you get this 48, ma? 32 plus 16. It means another half-life is completed. Then what will happen? Now third half-life is completed, no? Third half-life is completed. So it means N naught by 4, and in that one again divided by 2. So it will become N naught divided by 8. Okay. What is N naught divided by 8? Now only these many atoms are there which are ready to disintegrate. Remaining all the atoms have disintegrated. Even remaining atoms which are ready for disintegration. Are you able to understand? Now after 64 days, how many half-lives are completed, ma? 4 half-lives are completed. That is, the fourth half-life is also completed. Now how many atoms are present? N naught divided by 8 divided by 2. So N naught divided by 16. Okay, ma? So these many atoms are present for disintegration. Ivi unnavi, poinavi gadu ivi. These many atoms are there for disintegration. Okay, ma? So what is N naught by 16? N naught by 16 is number of atoms ready for disintegration. Are you able to understand? Okay, ma? These many atoms are ready for disintegration. Now, so what he is asking, fraction of atoms decayed. So decayed atoms are how many, ma?
N naught by 16 minus.
Decayed atoms are how many? Can you say? Total initial atoms N minus remaining atoms N naught by 16. So total how much? 16 N naught minus N naught divided by 16. So total how much? 15 n naught divided by 16. So these are the decayed atoms. Ante kada? Out of total atoms, these many atoms are present for disintegration. Remaining all the atoms have disintegrated. What is the initial number of atoms? N naught. How many atoms are present? N naught by 16. So original number lonchi ee number teeseste decay atoms vastayi kada. So how many atoms have decayed? 15 n naught by 16 atoms have decayed. Therefore, fraction, how can you calculate? Fraction is equals to decayed atoms by original atoms. That's all. No? This is the fraction. No? Decayed atoms, 15 n naught divided by 16 divided by n naught. N naught if you get cancelled, 15 by 16. So that is the fraction of atoms which have already decayed. Understood? చేస్తే వస్తుంది. అది అట్టగా సార్ ఇట్టగా సార్ అంటే ఏమొస్తుంది? ఏమి రాదు. ఓకే. So this is the general method of solving. Now if you use the equation, see whether you get the same answer or not. Okay. Equation kuda undi kada, shortcut equation. Now let us proceed according to the formula. Which is the formula? Formula is, this is the formula, no? Okay ma? See ma. N is equals to n naught multiplied by 1 by 2 power n. Okay, this is the equation, no? What is n here? Number of atoms undecayed. This is n, no? Which means which are ready for disintegration. Okay, ma? N naught means what? Original number of atoms. N means what? Number of half-lives. Number of half-lives. That is called n, no, ma? So, 1 half-life, 2 half-lives, 3. How many half-lives are gone? And what is the equation to calculate n? Total time divided by time taken for 1 half-life. All this we have done previously, no? Huh? What is the total time he gave? 64 years, 64 days. And what is the time taken for 1 half-life? 16. So 64 by 16 is how much? 4. It means how many half-lives have gone? 4 half-lives have gone. 4 half-life అయిపోయినాయి అని అర్థం. Are you able to understand? Total time is 64. Time taken for each half-life is 16. So 64 by 16, 4 half-lives have completed. Okay. So therefore, now substitute in this equation. So therefore, n is equals to n naught multiplied by 1 by 2 power 4. Okay. So therefore, how much? N is equals to n naught multiplied by 1 by 16. So therefore, n naught divided by 16. So same answer I got once again. Are you able to understand? And what is meant by n? N ante number of atoms which are ready for disintegration. And how many they are? They are only n naught by 16. So therefore, decayed atoms. Decayed atoms are how many? Cheppandi. Decayed atoms. These are the left atoms. ఇవి మిగిలి ఉన్నవి. ఎన్ని లేచిపోయినాయి? Again same formula. Total number is n naught minus remaining is n naught divided by 16. So therefore, decayed atoms is how much? 15 n naught divided by 16. Therefore, fraction, how can I calculate? Fraction is the fraction of decayed atoms is 15 n naught by 16 divided by n naught. So how much? 15 by 16. That's it. Same answer. Understood, Nama? That's it. Very simple. అర్థమవుతుందా? So once again when you go through this problem. Okay, ma? Next is. So this is the given question. Plutonium has a half-life of 24,000 years. Then what fraction of it will remain after 72,000 of years? Okay, very simple. Okay, ma. So 24 into 3 is 72, no? 24 3s are 72. It means that 3 half-lives are completed. That's it, no? 3 half-lives are completed. So therefore, I can say 3 half-lives have completed. So therefore, if I write about general method of solving, first method of solving, okay ma? So after 1 half-life, first half-life, how many atoms will be there? N naught divided by 2. Clear, na ma? After second half-life, n naught by 2 divided by 2, n naught by 4. These many atoms will be ready for disintegration. And after third half-life, okay ma? So n naught by 4 divided by again 2. So total how much ma? N naught by 8 atoms are ready for disintegration. And will remain. It means this only he is asking. So these many atoms are present for disintegration. That is my answer. N naught divided by 8. What fraction he is asking? No? Fraction means what I will do? Fraction means n naught by 8 divided by n naught. So 1 by 8. That is my answer. That is the fraction of atoms remaining for disintegration. Okay. If I want to do in a second method by using equation. Okay. So number of half-lives are 3. How many half-lives? 3 half-lives. So substitute. So n is equals to n naught power 1 by 2 power n. This is the equation number. Okay. So therefore n naught multiplied by 1 by 2 power 3, n naught divided by 8. Okay. So therefore again fraction, how can you calculate? N naught by 8 divided by n naught 1 by 8. That is the answer. That's all. No? So 1 by 8 the fraction of atoms are still ready for disintegration. That is the meaning of it. Okay. So Sima, let us see this question. So half-life of a radioactive substance is 30 days. Okay, ma? So half-life means we know half of the atoms to disintegrate and only half will be present. So for the time taken is 30 days. Ma? So what is the time taken for 3 by 4th of original mass to disintegrate? Okay. It means 3 by 4th are the remaining atoms or are they disintegrated atoms? Disintegrated atoms. That's all. No? So therefore left atoms are how many? Left atoms are how many? 1 by 4th is a fraction. My original number I can take 1. 1 minus 3 by 4. 1 minus 3 by 4 is nothing but 1 by 4. So 1 by 4th atoms are present for ready for disintegration. That is the meaning of this one. No? 3 by 4th of the mass has already disintegrated. So left mass is how much? 1 by 4. That's all. If original number if I take 1, 1 minus 3 by 4 is 1 by 4. So therefore 1 by 4th mass is present. Are you able to understand? So in which condition you will get 1 by 4? Ma? Very simple. 1 converts into 1 by 2 after 30 days. That's all. 1 converts into 1 by 2 after how many days? 30 days. 30 days half-life already he gave. 1 by 2 converts into 1 by 4 after another 30 days. So total time is, so that's all. Very simple. Okay. So very carefully you should read the question first of all, and then you have to identify what is the meaning of each word which we have written in the equation. Okay. Or if you want to solve according to the equation, how can I solve? Let us see. So n is equals to n naught power 1 by 2 power n. Are you able to understand now? So therefore n means what here? Number of atoms which are left, which are ready for disintegration, and that is 1 by 4. Okay. So or you can write n by 4. N by 4 or n naught by 4. Original number of atoms n naught. So n naught by 4 are ready for disintegration. So this is equals to n naught multiplied by 1 by 2 power n. N naught you cancel. So 1 by 4 is equals to 1 by 2 power n. Okay, ma? 1 by 4 also can be written as 1 by 2 whole square, no? So 1 by 2 power n. So therefore what is n? N is equal to 2. That's all, no? Ma? What is n is equal to 2? 2 half-lives. N is number of half-lives only, no? 2 half-lives. Therefore 30, no? 30 plus 30. 60 days. Or you can say 2 into 30. 60 days. That's all. అర్థమవుతుంది కదా హాఫ్ లైఫ్ ఎలా ఫైండ్ అవుట్ చేయాలో? వెరీ సింపుల్. Sima. So see here, 10% of radioactive material decays in 5 days. That's what he gave, no? Then what would be the percentage of amount of original atoms left undecayed after 20 days? That's what he's asking, no? So this problem just you can do like half-life only. For first half-life, for example, consider 5 days. For next half-life also, 5 days. Are you able to understand, no? But after first half-life, 1 by 2 atoms, n naught by 2 will be there. That is 50% of the atoms have disintegrated. After second half-life, n naught by 2 again by 2. n naught by 4. It means 25% are remaining, 75% have disintegrated just after 2 half-lives. Same procedure you can apply here also. Okay, so let us see. So after 5 days, clear nama? So how much percent have disintegrated ba? 10%. It means the remaining will be how much?
90%.
Remaining will be 90%. That's all. Okay. 90%, how can I write? I can write 90 by 100 multiplied by n naught. Can I write like this? 90%. So after 5 days, that is after 5 days, 10% is disappeared, that is 10% have disintegrated, and 90% have not disintegrated. Okay, now listen very carefully. After another 5 days, that is after total 10 days, again what will happen? Again, in the remaining number of atoms, again 10% should disintegrate. Ante kada? So what you are doing is 10 plus 20 plus 30 plus 40. 40% have disintegrated. Konda calculation lo chesta unnaru meeru. Arthamavutundi kada? So in left atoms, again 10% will be disintegrated. Remaining atoms only this much, no? Ive kada migili unna atoms. In this remaining atoms, 10% should again disintegrate. Okay. So after another 5 days, again what will be the remaining number of atoms? 90% of this value. 90 by 100 multiplied by n naught. That's all. After another 5 days, another 10% of remaining atoms have disintegrated.
90%.
Disintegrate ainavevi 10%. Remaining will be how much? 90%. 90% of what? Remaining atoms. 90% of 90%. Those are the remaining atoms. Understand? So therefore, how can I write? I can write again 90 by 100 multiplied by 90 by 100 multiplied by n naught. Clear nama? So 90 by 100 whole square multiplied by n naught. Okay. So total how many days completed ba? 10 days completed. So write down after another 5 days. After another 5 days, so total how many days? 15 days. Now what is the remaining atoms? Okay ma? Remaining will be how much? Again it is 90% of these atoms. 90 by 100 whole square multiplied by n naught. That's all. No? So therefore can I write it as 90 by 100 whole cube multiplied by n naught. That's all. No? So therefore finally after 20 days, that means after another 5 days, definitely it should be 90 by 100 power 4 multiplied by n naught. That's all. No? So this will be the remaining atoms. Okay, and if you do this calculation, it is approximately 65.6%. That's all. That is my answer. 90 by 100 you can write 9 by 10, no? So do 9 by 10 to the power of 4, then this is the answer which you will get. You will get a fraction, no? Fraction you multiplied by 100, then this is what you will get. Okay? Or if you want to do calculation here, you can do. So therefore, percentage left undecayed is how much? 90 by 100 whole power 4 multiplied by n naught multiplied by 100. So 65.6%. That's it. In half-life also, this was the method we have followed, no? So for any percentage, you have to follow the same method. Half-life means 50%. Here instead of 50%, what he gave? 10%. But whatever it may be, calculations remain same. Okay? That's it. Okay, na? So, student. So next concept is average life or mean life. See ma here. So when a atom will disintegrate, we don't have any idea, no ma? According to Rutherford's law of radioactivity. When an atom disintegrates or when an atom doesn't disintegrate, we don't have any idea. So what we do is we take the average life of each atom present in a radioactive substance. And how can I calculate that one? Sum of lives of all atoms. For example, if 100 atoms are present, so what is the time taken for all the 100 atoms to disintegrate? Are you able to understand? Ma? Or if you say first atom is disintegrating after 3 hours, second atom is disintegrating after 100 years, anything can happen. So you take the sum of lives of all the atoms divided by total number of atoms. Then you will get average life only. No? Are you able to understand? Ma? It means on an average, after how much time an atom will disintegrate. That is called as average life. So sum of lives of all atoms divided by total number of atoms, average. Okay, and the relation between average lifetime and decay constant, this is the relation. T average is exactly equal to the reciprocal of lambda. Okay, similarly I want to calculate a relation between, okay ma, relation between T average and T half. So what is the meaning of this two? I don't know. So T average means what? Average lifetime. And T 1 by 2 means time taken for half lifetime. I want to derive a relation between them. How can I derive? Let us see. Okay, see ma here, T average is equals to 1 by lambda. No? Lambda can be written as 0.693 divided by T half life. No? Already we have written this equation. No? So substitute here. Therefore 1 by lambda value is how much? 0.693 divided by T half. Okay, so therefore T average is equals to T half life divided by 0.693. So therefore half life is how much? 0.693 multiplied by T average, or also you can write, here I will write down, 0.693 is nothing but log 2 to the base e. No? So T 1 by 2 can be written as log 2 to the base e multiplied by T average. So this is the relation between half life and T average. Understood? So these relations you should remember. Okay, ఈ రిలేషన్స్ అన్నీ మీకు గుర్తు. Okay, so the next concept which we are studying is activity. So what is meant by activity? Number of disintegrations per second is just called as activity. So already we have studied dN by dt previously, no? That itself is called as activity. Are you able to understand? So what is meant by dN by dt? Number of disintegrations per second is called as activity. Are you able to understand? So therefore, let us see. So A is equals to minus dN by dt, and it is directly proportional to n. Already we have studied previously. No? Number of disintegrations per second depend on what? Initial number of atoms. If number of atoms are greater, more disintegrations will happen. Clear? No? So therefore I can write A is proportional to n. Okay, and we know that A is equals to lambda into n. No? This relation was written like this only. No? So minus dN by dt is equals to lambda into n. So here also I am writing lambda into n. So this is how I can write equation of activity. So activity is nothing but dN by dt, and it is equal to lambda into n. Okay, then again what I can write is at t is equals to t naught. Okay, ma? Or when you say when t naught is equal to 0, that is at initial time. When you started observation, then activity I can write it as, then activity will be A naught. That's all, no? Ma? When you started observation, then at that time activity I can write it as A naught. And same equation how I can write at the same time, A naught is equals to lambda into n naught. I can write like this also, no? So this is the activity after some time now. Okay, this is the activity at a time, at a or after some time, after some time. Okay, and this is the activity initially. So therefore if you divide both of them, I can write A divided by A naught is equals to lambda m divided by lambda n naught. So lambda get cancelled. So A divided by A naught is equals to n divided by n naught. So this is one important equation. Okay, A means activity, A naught means initial activity, n means number of atoms ready for disintegration after some time, n naught means initial number of atoms which were ready for disintegration. Okay, and already we have studied that n is equals to n naught e power minus lambda into t. This already we have studied now. So take that and substitute here. So therefore A by A naught is equals to n naught e power minus lambda t divided by n naught. N naught you can cancel now. So therefore A is equals to A naught e power minus lambda into t. So this is another equation which gives relation between initial activity and final activity. Okay, ma? So A is activity at present, that is after a time of t, and A naught is the initial activity before a time of t. So questions can be asked on this one also. Understood, Nama? That's it. Okay. Same relation I can write like this also, na? A divided by A naught N, how I can write? N naught power 1 by 2 power N also I can write to in terms of number of half-lives. So divided by N naught. So N naught if they get cancelled. So A by A naught is equals to 1 by 2 power N. So you can write like this also. Or you can write A is equals to A naught multiplied by 1 by 2 power N. You can write like this also. Understood, Toma? Where N here, N is number of half-lives. N is number of half-lives. So write that also. Number of half-lives. So if there are 2 half-lives completed, then I will write N value is 2. 3 half-lives completed, I will write N value is 3, like that. Fine? That's it. Okay, ma? So, next we are studying about units of activity, or unit of radioactivity. So, the first one which we have to study is Curie. Okay, ma? 1 Curie is equal to how many disintegrations? 3.7 into 10 power 10 disintegrations per second. And what is meant by disintegrations? Already we have studied, no, ma? So, if this many atoms are disintegrating in 1 second, then it is called as 1 Curie. Clear, no? And disintegration means what? Either emission of alpha particle or beta. But if alpha is emitted, then also it is called disintegration. If beta is emitted, then also it is called as disintegration. Okay. Next, Becquerel. So 1 Becquerel is nothing but 1 disintegration per 1 second. Okay. If 1 atom is disintegrating in 1 second, then it is called as Becquerel. So obviously, I can write 1 Curie is equal to 3.7 into 10 power 10 BQ. Because this many disintegration is called as 1 Curie. And what is meant by Rutherford? 1 Rutherford is 10 power 6 disintegrations per second. So these are some of the units of radioactivity, or you can call it as activity. Activity is also called as dN divided by dt, number of disintegrations per second is called as activity. Okay. Okay. So see this question. So calculate the kinetic energy and speed of alpha particle. Okay, ma? Emitted when uranium decays into thorium and when alpha particle is released. Okay. So see here what is the process which is happening, ma? So uranium 92 and 232, it is converting into thorium 90 to 28. This is what is happening, no? Clear, no? So what is happening to proton number, ma? Proton number decreased by how much factor? 2. What happened to mass number? Mass number reduced by 4, no? Clear, no? It means definitely alpha particle would have been released. That's all, no? Because the proton number or the charge of alpha particle is 2. And what is its mass number? Mass number is 4. So definitely this should have been the process which should have been done. Okay. So what he is asking, you are supposed to find out the kinetic energy and speed of alpha particle emitted in this condition. Okay. First of all, can you say how this alpha particle got this kinetic energy, ma? Why this alpha particle should get energy? Just to release out the chalgada. But he is saying that after releasing, alpha particle is having some velocity also. That's what he is saying, no? So how this alpha particle got this velocity?
They got more energy than required.
How it got more energy? How it got more energy?
We provided.
We did not provide. This process is occurring naturally. Radioactivity nobody can force. Now already we have studied Rutherford's law of radioactivity. No? Radioactivity does never depend upon temperature, pressure or any other external factor. It should happen by itself. Okay, but never control failure. Is it clear? So energy would have been obtained by alpha particle only because some mass should have been converted into energy. That is the only option which we have. Clear? Now see here, let us calculate mass defect. What is meant by mass defect, ma? Mass defect means what? The amount of mass which has disappeared and converted into energy. That is called as mass defect, you know. So calculate. What is the initial mass of uranium 92 to 232, ma? It is given, no? So 232.03714 minus of, clear, no, ma? So now it is finally converting into thorium and an alpha particle. So thorium mass is 228.02873 plus, and what is the mass of alpha particle? 4.002603. Clear, no? So if you do this calculation, then you will get the amount of mass which has disappeared. Understood, no? So let us see what is the value which he gave. So it is 0.00 0.00581. So 0.00581 million electron volts of energy has been, mass has been, this is in AMU's number, atomic mass units. Okay. So this much amount of mass has been disappeared. Are you able to understand? Now when this mass has disappeared, okay, now what is the energy that should have been released? Energy released, how can I calculate?
0.00581
Into 931.5. So previously we studied that if 1 AMU it is converted into energy. AMU is the unit of mass only, no? Mass, small masses, atomic masses we study in the case of AMU. So 1 AMU if it is converted into energy, then 931.5 million electron volts of energy will be released. Already we have studied, no? Clear, no? So therefore do this calculation. So energy released how much? 0.00581 multiplied by 931.5 million electron volts. If you do this calculation, then you will get the total amount of energy which is released. Okay, make a note. Okay, ma? So now see. So therefore this much amount of energy will be released, ma. Let us see how much will be that energy. 5.4 million electron volts. Okay, ma? So this much amount of energy will be released. Okay. Now out of this total energy, can I say that this will be the energy of alpha particle? This is the total amount of energy is released. Can I say this will be the energy obtained by alpha particle? Can I say or not? I cannot say, because there are two products. Thorium atom is also released, alpha particle is also released. So some of the energy will be taken by thorium and remaining energy will be taken by helium also. Are you able to understand? So therefore thorium also will get some kinetic energy. Similarly alpha particle also will get some kinetic energy. Are you able to understand? So if I consider this total energy of Q, total energy if I consider to be Q, then what is the energy obtained by alpha particle? I can write like this. Okay, ma? So energy obtained by alpha particle. Okay. Alpha particle, there is a formula. And what is that one? It is A minus 4 divided by A multiplied by Q. This is the amount of energy obtained by alpha particle. Are you able to understand, ma? What is meant by A there? A means mass number. So what is the mass number of uranium? It is equals to 232. And 4 is the mass number of what? Helium, nucleus. Multiplied by Q. And what is meant by Q, ma? Q is the total amount of energy released. Clear? So substitute the values and see what is the answer you will get. Clear? So therefore 232 minus 4 divided by 232 multiplied by total energy released is 5.4 million electron volts. So if you do this calculation, approximately it is 5.3 million electron volts of energy. That will be the amount of energy which will be obtained by alpha particle. Understood, Nama? Alpha particle will get this much amount of energy. Okay? Come on, make a note. Next, we have to calculate kinetic energy also, Nama. Kinetic energy we have calculated. Speed, now we have to calculate. So, this is the energy taken by alpha particle, and energy will be always taken in the form of speed, kinetic energy of the alpha particle. Now, how can I calculate this alpha particle will travel with how much speed? Can you say? How can I calculate? Speed ela calculate cheyali? See, kinetic energy of alpha particle, already we have calculated now how much it is, 5.3 million electron volts, and kinetic energy is nothing but half mv square, no ma? Kinetic energy is nothing but half mv square. So therefore velocity is nothing but square root of 2 into kinetic energy divided by mass. I can write like this, no? 2 into kinetic energy divided by mass root, that will be the amount of speed of the alpha particle. Clear? That's all, no? Now substitute. So square root of 2 into, what is the kinetic energy obtained? 5.3 million electron volts. So I will try to calculate in terms of meters per second. So million is nothing but 10 power 6. Okay, ma? And 1 electron volt is equal to how many joules in SI system? 1.6 into 10 power minus 19 joules. Already we have calculated, no? So 1 electron volt is equal to 1.6 into 10 power minus 19 joules. This is the amount of energy which is equivalent to 1 electron volt. Clear, no? So divided by what is the mass of alpha particle, ma? Mass of the alpha particle already given, nearly 4 AMU. Okay, ma? So 4 into 1 AMU is again how much? 1 AMU is equals to 1.66 into 10 power minus 27 kg. That's all, no? So that value also I am writing here. 1 AMU is equal to how many kgs, ma? So 1.66 into 10 power minus 27 kg. So all the values I have substituted in SI system. So answer also I will get in SI system. Okay. So if you do this calculation, the answer which you will get will be in terms of meters per second. Okay. So the answer is 1.6 into 10 power 7. 1.6 into 10 power 7. 10 power 7 meters per second. That is my answer. Clear, ma, how we have calculated? Very simple. So just this formula you should remember, ma. Okay, ma. So let us see this question. So here what is happening is uranium 92-238, it is decayed into lead, plumbum 82 and 206. Clear, no? So already we have studied that plumbum 82, above these all the elements they are unstable. Only up to 82 only the elements are stable. After that the elements they are not stable. So uranium, after many decays, after continuously emitting alpha and beta radiations, finally it converted into plumbum 82 and 206. Then in this process, how many alpha particles will be emitted and how many beta particles will be emitted? That is the question. Clear, Nama? First of all, let us study about alpha decay. Okay. So when one alpha particle decays, what happens? Okay, alpha particle బయటికి వెళ్ళిపోతే ఏమవుతుంది? Proton number reduces by 2, mass number reduces by 4. So therefore, atomic number reduces by how much, ma? Atomic number reduces by 2 and mass number reduces by 4 units. This is what we have studied, because alpha particle is nothing but helium nucleus. Helium 2 and 4 is called as an alpha particle. So when one alpha particle goes out, so proton number reduces by 2, mass number reduces by 4. Okay. Next, what happens when beta particle goes out, ma? When one beta particle is emitted, then what will happen? Come on. Atomic number increases by how much? Increases by 1 unit. Clear, no? And mass number? Mass number does not change. Okay. Mass number will never change when beta particle is released, because already we have studied, no? How beta particle is released? One neutron, clear, nama? One neutron converts into proton plus beta particle. So one neutron is reducing, but one proton is newly created, no? Okay. So therefore, one uncharged particle has reduced and one charged particle has increased. So therefore, definitely atomic number increases. But 1 AMU has disappeared, 1 AMU is created, so mass number does not change. This is what we have studied, no? So now see, now we will take this point into consideration and we will try to do the calculation. Okay, now see. So mass number never changes. So whatever may be the amount of beta particles which are released, 2, 3, 4, 5, 6, any number of beta particles, mass number never changes. So first you take mass number. Okay, ma? So uranium 92-238, it is converted into 206, no, ma? So therefore, what is the reduction in mass number? 238 minus 206 is how much, ma? 32. So this is the reduction in mass number. And mass number can reduce by what? Mass number దేని వల్ల తగ్గుతుంది? Only because of alpha particles. Beta particles never change the mass number. That's what we have studied, no? So therefore, alpha particles. So number of alpha particles, how can I calculate? Okay, ma? Definitely 32 divided by 4. 32 divided by 4 is how much? 8. 8 alpha particles are released. That's all, no? Because mass of each alpha particle, 4. 8 4s are 32. Reduction in mass number is 32 only, no? So definitely 8 alpha particles would have been released. That's all, no, ma? That's it. Clear? Now let us calculate about how many beta particles are emitted. Okay? See, when one beta particle is emitted, mass number increases by 1. atomic number increases by 1 and mass number does not change. Okay. Now if you take atomic number, okay, atomic number, are you able to understand? It converted into what? So it converted into 92 to 82. Okay. So therefore, now see how we can do this calculation. So 92 minus of how many alpha particles? 8 alpha particles. And with each alpha particle, proton number has reduced by 2, no? వినండి చాలా కేర్ఫుల్గా వినాలి. ముందే మన కోడి బ్రెయిన్స్, మనుషులంత బ్రెయిన్ కూడా లేదు, కోళ్ళకున్నంత మాత్రమే ఉంది. సో కేర్ఫుల్గా వినండి ఫస్ట్. సో 92 మైనస్ how many alpha particles are released? 8 alpha particles. And with each alpha particle, proton number reduces by how much? 2. So can I write 92 minus 8 into 2? That's all, Nama. 92 converted into 82, Nama. 92 converted into 82. So 92 minus how many alpha particles? 8. With each alpha particle, atomic number reduces by 2. And we are discussing about atomic number only, no? 92 is atomic number. So 92 minus 8 into 2. Because 8 alpha particles are released. And how many beta particles are released? I don't know. Let it be B. Okay, ma? And with each beta particle, one proton number will increase, no? If one beta particle is released, what happens to atomic number? Increases. So can I write a beta into 1? Plus beta into 1. Minus 8 into 2, but plus beta into 1. Why minus 8 into 2? 8 alphas are released. So therefore, proton number decreases by 2 for each alpha. But for each beta, what happens to proton number? Proton number increases. So plus I am writing. For alpha I am writing minus, for beta I am writing plus because it increases. And total should be how much? Total should be 82. That's all. From 92 I am removing this value and adding this value, then finally it should be 82. Now calculate beta value. Clear, Nama? So therefore beta value is how much? Okay. So therefore beta is equals to 82 minus 92 plus 60. Clear, Nama? So beta is equals to minus 10 plus 60. So how much? 6. So therefore how many beta particles are released? 6 beta particles are released. So this is the method of calculation. Are you able to understand? So first you proceed with that value which never changes. Okay. So mass number never changes, no? In which condition? When alpha particle is released, when beta particle is released, mass number never changes. Clear? So therefore, in conversion from 238 to 206, the contribution should be only because of alpha. Because only when alpha is released, then only mass number will change. So change in mass number is only because of alpha only. Okay? Mass number మారిందంటే దేని వల్ల మారుంటుంది? కేవలం ఆల్ఫా వల్ల. బీటా మాస్ నెంబర్ని మార్చలేదు కదా. సో ఫస్ట్ యూ క్యాల్కులేట్ దట్ వన్, 8 alpha. Then you go for the atomic number. Then I can do very easily. Clear, no? And in changing atomic number, both will be helpful. So when alpha is released, then also proton number will change. When beta is released, then also alpha value will change. So in the second condition, I have taken atomic number and I have done the calculation. అర్థమైందా ఎలా చేసాము? That's it.